Welcome everyone to the Physicians Committee's Mission Critical Update with Dr. Neil Barnard. And thank you for joining us. Today is December 11th, 2020. I'm Betsy Wasson, Vice President of Development here at PCRM, and we're really glad that you're joining us today. So we've got a treat for you, as always. Dr. Barnard will be joined by staff dietitian Megan Jardine and our Medical Research Program Director, Dr. Ann Lamb. And how does PCRM work to promote good health that also saves animals? Well, we're going to hear all about it coming up. For today's event, please use the chat box. Tell us where you're coming from, say hello, and when you choose to write your comment, there's a drop down that says send to all attendees and panelists. And when you choose that option, it will let everyone see your messages, and that's a lot more fun. And I'm going to go ahead and turn it right over to the Physician Committee's founder and president, Dr. Neil Barnard, so we can get started with this week's Mission Critical.
Well, thank you, Betsy, and thanks to everybody for joining us. If you haven't yet had a chance to jump in the chat, please do, and just say hi and let us know where you're from. We'd love to welcome you. Thank you for, I guess I should say really thank you to everybody for having been with us on the Mission Criticals that we've had this year. This has been a goofy year, to say the least, and I'm hoping we don't do this year again. Anyway, we'll talk more about that next week when we kind of do a year-end wrap-up. But for today, I want to talk about some of our clinical research. Many of you have helped support the clinical research studies that we've done. And last week we talked about this huge study that we did in partnership with Yale University, where Dr. Anna Kaliova brought in 244 people here into our office. Half of them went on a vegan diet, the other half stayed on their regular diet, and we tracked the really remarkable differences that we saw over time from weight loss, but then also improving insulin sensitivity, which means reduced risk for diabetes, and also perhaps the big breakthrough was not just that people lose weight, but why? Because we were able to look inside their cells and see how their intramyocellular lipid and hepatocellular lipid dissipate and people regain health. So that's basically a short way of saying the scientific community loves this kind of research. And so does the Dietary Guidelines Advisory Committee, which we'll be meeting again later. Okay, but for now, what I wanted to do today is I wanted to mention a spin-off of that study that's a really cool one. As you know, people have been looking for every reason to do every other kind of diet other than a plant-based diet. Let's do keto, let's do Mediterranean, let's do the blood type diet. Well, we've been looking into these kinds of diets, and today I want to focus on the blood type diet. And let me share my screen, I'll show you what I'm talking about. Okay. On your blood cells, there are what we call antigens on the surface. These are proteins that can be recognized by your immune system. And if you are type O, then you don't have some of these special antigens, but there are A antigens and B antigens. And let's say your mom gave you type A antigens, or maybe both your mom and dad did, and you got type A blood. Let's say you got type B antigens, then your blood type B, but you can be both. You can have A and B. So those are the four major blood types, O, A, B, and AB. And researchers have been looking into whether these are associated with different kinds of health outcomes, and they actually are. Back in 2016, people who had blood group A had slightly increased risk of coronary artery disease compared to people who didn't have type A. Now, this is not huge, but it's real. And people who had blood group O, which is the most common type, had slightly reduced coronary artery disease risk compared to other people. Again, these differences aren't huge, but there's a slight advantage for O and a slight disadvantage for A. And lest we think this is a fluke finding, it isn't. The Nurses' Health Study and the Health Professionals Follow-Up Study, both done at Harvard, the nurses, all women, the health professionals, all men, in this case, they combined them all together. And the people who did not have type O were a little bit more likely to have heart disease. Okay, so then when COVID started coming in, people, I think correctly, started to think, well, if let's say type O is a little bit of a cardiovascular advantage, maybe you're going to do better. If type A is a little bit of a cardiovascular disadvantage, maybe you're going to do a little bit worse. And that's really what seemed to be true, actually. This study came out from China, over 2,000 people, so big study. And it's true, blood group A a little bit more susceptible, blood group O a little bit less susceptible. And then the risk of whether you had respiratory failure. Blood group A more susceptible, blood group O less susceptible. So, okay, so all these things show that if you got type O blood, you're a little bit better off in all these ways. 1996, a well-meaning doctor, PhD, Peter Diadamo, said, okay, well, you should eat based on your blood type. And the idea was, let's say you're blood type A. Well, you should have fruits and vegetables. Well, maybe you should. But if you're blood type O, well, you need meat. That was the big thing. And if you're type AB, it's a little different. Type B, it's something else. And this became quite a fad because it sounded like personalized medicine. You're going to select the diet that's the perfect fit for you. So if I'm blood type A, a vegan diet would be great. But if I'm blood type O, sorry, can't do vegan. I need a pork chop. And to this day, you'll hear people say that. I'm blood type O, I can't be vegan. Well, we were suspicious of that because type O is the most common blood type. I'm type O, you might be too. And a lot of the people in our research studies with type O, and they seem to do pretty well on a vegan diet, despite the book saying they should. So we decided to look at it in an organized way. We brought in 68 volunteers. Everybody was overweight, and every single person was put on a low-fat vegan diet, regardless of their blood type. And then we compared if you're type A, who's supposed to be vegan, or you're not type A, who's not supposed to be vegan, how do you do? And same with type O. For you, a vegan diet is supposed to be out compared to the non-Os. Here's what we found. Okay, for weight loss, the average person with type A on a vegan diet over 16 weeks lost 5.7 kilograms. Pretty good. What's that about? Maybe call it 12, 13 pounds, something like that. The people who were not type A and supposedly weren't supposed to be vegan, they did just as well. In fact, they did a little bit better. They lost 7 kilograms. Call that what, 15, 16 pounds. All right. Then what about the type O? Type O, these are the people who, according to the book, are not supposed to be vegan at all. Wait a minute. They're doing great. They lost 7.1 kilograms. And the people who are non-O lost 6.2. So it looks like no matter what your blood type is, if you go on a low-fat vegan diet, it's going to help you. All right, but how about cholesterol? Let's look at your LDL cholesterol. That's bad cholesterol. Type A's, they do pretty good. 11 points off their bad cholesterol in 16 weeks. Pretty impressive. But wait a minute. The people who are not type A do well too. In fact, they do a little bit better. And now the type O's, they're definitely supposed to be not vegan. Oh, wait a minute. They're doing great on a vegan diet, and so is everybody. So it really looks like there are slight differences in disease vulnerability based on blood type. But none of that means that a vegan diet is not a good idea. It turns out that a low-fat, completely plant-based diet is good for type A, type B, type AB, and yes, type O. So doesn't that make life simpler? These results were published last week in the Journal of the Academy of Nutrition and Dietetics. Back to you, Betsy.
Thank you, Dr. Barnard, and I am very glad that we don't have to worry about what to eat to match our blood type, and thank you for sharing the evidence with us about that. I'm going to go ahead and introduce our next presenter. Megan Jardine is PCRM's Director of Diabetes Nutrition Education, and this is her first time joining us on Mission Critical. We really value having you meet as many PCRM staff members as possible, and Megan is joining us today from her home base in Dallas. So we know that so much of our overall health can be linked to our gut microbiome. And Megan has educated so many healthcare professionals about this topic. Today, she's going to share some of that wisdom about gut health with us. Over to you, Megan.
Thank you. Hi, everyone. I'm going to go ahead and start this, share my screen. Okay, great. So I'm going to talk to you about how a plant-based diet can improve the health of your gut bacteria. But first, I want to do a little poll. So have you heard the terms microbiome or microbiota? I'm just going to give you a minute to select yes, and I've done a lot of reading about this subject, yes, but I'm not really sure what these terms are, or no, I've never heard of this. Okay, what do we got here? Okay, so a lot of you know about microbiome and microbiota. Okay, so, and some of you aren't quite sure. So, you know, I had to learn about these terms, and here is the difference. The microbiota just refers to the species of bacteria that's in a specific sample. And the microbiome is the genetic makeup, the collective genetic makeup. And these genes are very important because they tell us what the bacteria do. Bacteria actually produce metabolites or chemicals that affect our health. So the microbiome helps our nutritional status. These bacteria digest food. They also produce vitamins and amino acids. So without bacteria, our nutritional status would be affected. Healthy bacteria prevent the colonization of pathogens. So if we have a healthy microbiome, we're going to have fewer infections. Healthy bacteria play a role in hormone regulation, mood and behavior. And did you know that 70 to 90% of serotonin is produced in our gut? Scientists have also found that there's a connection between our brain and our gut. So if you've ever had a gut feeling about something, that could actually be your bacteria talking to your brain. So what happens when the microbiome's not so healthy? This is called dysbiosis. And this means that there's more unhealthy bacteria and they're taking over. And so there's fewer healthy bacteria. And dysbiosis has been associated with a lot of chronic diseases. This is sort of a limited list. I'm a diabetes educator, so I've studied a lot about dysbiosis and diabetes, but it's also associated with cardiovascular disease. And new evidence has shown that it's associated with Alzheimer's disease as well. So there are many lifestyle factors that promote dysbiosis. It can be stress, lack of exercise, not enough sleep, but the most important factor is nutrition. Animal products, fatty foods, fried foods, processed foods, these foods feed that bad or unhealthy bacteria and it thrives. And it also starts to produce toxic metabolites that promote inflammation in the body. And this is what's associated with obesity, diabetes, and Alzheimer's disease. One metabolite that's been studied a lot is called lipopolysaccharide. And a healthy plant-based diet can actually help with that. So let's take another poll. So which of these foods are prebiotic? You can check all that apply. And just a hint, prebiotics help feed healthy bacteria so that they can thrive. So go ahead and vote. We've got dandelion greens, asparagus, onions, leeks, oatmeal. Do we have some results? Okay. Dandelion greens, asparagus, onions, leeks, oatmeal, apples, pears. Yeah, you guys are doing great. Okay, so interestingly, foods that improve the health of your microbiome also improve brain health and prevent Alzheimer's disease. Have you ever tried dandelion greens? These are greens that you can buy in the grocery store. Most grocery stores have dandelion greens. You can cook them like spinach, put them on stews, put them in soups. I remember My father used to go out in our yard in the spring and cut the dandelion greens on our lawn, and he would boil them, he would eat them, and he would even drink the water. And I had no idea he was, and he probably didn't know, he was feeding his microbiome. So all of these foods are important, mostly plant-based foods, fruits, vegetables, whole grains, beans, all improve our microbiome. Foods that keep the brain healthy are the same foods. Also include foods that are high in vitamin E, like spinach, broccoli, sweet potatoes, mangoes. Vitamin B12 is also important. So if you're following a vegan diet, make sure you take your vitamin B12 because that's important to maintain brain health. B12 for brain health. So all of these foods are high in fiber, and this is what feeds the healthy bacteria. And when you feed your healthy bacteria fiber, they produce healthier metabolites. These metabolites are called short-chain fatty acids, and they reduce inflammation in the body. They prevent diabetes. They are neuroprotective for your brain, and they do a lot of things. I could go on and on. We could probably talk all day about short-chain fatty acids and health. So for you to improve your brain health and the health of your gut bacteria, eat more vegetables, add beans to your diet, and avoid animal products, especially fatty meats, fatty foods, and processed foods. So thank you so much. And Betsy.
Thank you, Megan. That's a lot of good information, and we have a lot of good information, additional information on our website too. So if you want to know more, you can go to PCRM.org. On our homepage, there's a search bar. Just type microbiome into the search bar and all kinds of resources will pop up. So thank you again, Megan. We also have so many people chatting away, and I'd like to say hello to Anil in Short Hills, and howdy right back to Matthew in Ohio. And Serene is joining us from Jordan. Thank you all for tuning in today to hear about PCRM's work. So now we're going to welcome back Dr. Ann Lamb to Mission Critical. So Dr. Lamb is the lead architect in PCRM's Alzheimer's project. She's spearheading our efforts to advance new research strategies for understanding Alzheimer's disease and other dementias and moving away from animal experiments. So Dr. Lamb has some information to share with us on the link between gut health and brain health. Over to you, Dr. Lamb.
Thanks so much, Betsy. And thank you, Megan, for that wonderful talk about gut microbiome, which fits so beautifully with really understanding how a healthy gut can really help and be protective for brain function, and also how an unhealthy gut microbiome might lead to negative impacts like Alzheimer's disease. So I'm going to focus on how we can use human relevant methods to explore this particular topic in greater depth. So let's just click on, there we go. So as Megan described, we can see that, I don't know, can you guys see my mouse actually waving around? All right, at the bottom here, we see these influential factors of nutrition and how important it is to sort of eat healthy foods, stay away from those other ones, because on the left-hand side, you can see how really good gut microbiome and biota can encourage protective brain factors, and negative, and when things are unhealthy, you can lead to brain inflammation type events, and also loss of cells or connections for the brain to function properly. And so how that relates to Alzheimer's disease, which we understand in general as being something related to memory loss, is that Alzheimer's disease is now being recognized as a life course disease. This is something that doesn't just happen when you get old. This is something that is developing over time. And at the preclinical AD, or for there are no symptoms. There's still a lot going on biologically, and a lot of things, a lot of factors that are being that are at play. And as we we progress along the stages of Alzheimer's disease to the severe stages, we're talking about symptoms that are not as simple as saying, oh, there's some memory loss, but rather these symptoms are so severe that they interfere with most everyday activities. And with almost 6 million Americans today living with dementia, some form of dementia, this is a really, really large issue. And so understanding the factors, which we now recognize as age, genetics, family history, sex, race and ethnicity, and most interestingly, environmental modifiable risk factors, we are starting to understand that the complexity of Alzheimer's disease really cannot be recapitulated in animal experiments. Of course, PCRM always knew this, but now more people are coming around to this. And that's because whether it's looking at factors like cessation of smoking, eating well, understanding the role of social interactions, really the mouse is not a good model for this, and other animals are not a good model for this. And the reason why is due to differences in genetics, as well as those complexities that also lie in the environment, where again, when you look at the combination of factors like ethnicity, and that can be due to in differences in genetics, and then combining that with lifestyle risk factors like whether or not there's access to exercise opportunities, or where you live, for example, in rural perhaps versus urban areas, that can greatly affect the risk of developing dementia and Alzheimer's disease. And let me just give you an example here from some of our allies. This is a recent report published by Us Against Alzheimer's, where they showed that these factors, these environmental modifiable risk factors that include diabetes, obesity, physical inactivity, smoking, and insufficiency, the majority of them in places, in counties, in the United States, where there was the highest risk of developing Alzheimer's disease, that there was this interaction with these factors and where you lived. And this was a study that was done in Black and Latino, looking at patient and individual data in Black and Latino communities, because these two communities are disproportionately affected by Alzheimer's disease. So with human-based approaches like epidemiology and harnessing patient and individual data, we can address not just issues of complexity in lifestyle risk factors, but we can also start to understand important things like health disparities. Now, a much larger study that was done, that was published last year in the Journal of Alzheimer's and Dementia, showed this group led by Duke University and the University of Indiana, where they were looking at how exactly, going back to the gut microbiome, how does the gut microbiome affect Alzheimer's disease? And what the group did was use 3 very powerful human-based approaches, looking at genome analysis, and then utilizing the human tissue, brain tissue from postmortem donors, and also serum studies from live subjects in these groups that were based in both the US and in Europe, and combine that with the patient demographic data. And they were able to see that the bile acids that were being expressed by individuals with either mild, moderate, or severe Alzheimer's disease differed. And that affected the bile acid expression, and correlated very closely, or were associated with the risk genes for Alzheimer's and cognitive impairment. So we're starting to see this more complex picture emerge, where again, something from what we used to see as being outside the brain having a very important effect on the brain itself. So what we can now do with this, with these types of findings, is to use further human-based approaches, such as human-derived cell cultures, computational modeling, neuroimaging, and more studies using biospecimen and clinical data, and we can integrate everything from the smallest of the genomes information to the largest of the populations. And this is going to be critical in developing effective treatment and prevention strategies, most of all to diseases like Alzheimer's. And so if you'd like to hear more about human-based approaches, human-relevant approaches, please visit us at PCRM, pcrm.org/news/ethical science news, where we post and report on research around the world that is happening to show how we can more effectively study and combat these types of disease. And then back over to you, Betsy. Thank you so much.
Thank you, Dr. Lamb. It's fascinating stuff, and thank you so much for the work you're doing to push the research towards human-based methods. On Sunday, we held our virtual celebration for PCRM's 35th anniversary, and it was so much fun, and I hope you got a chance to participate and join us. Some of you submitted comments that were scrolling along the bottom of the screen during the event, and those were so heartwarming to see. Also, during the event, we launched our matching gift challenge, and if you did not get a chance to donate during the event, you can still have your gift doubled before the end of the year. So making a gift to PCRM will allow us to continue helping people, modernizing medicine, and stopping animal cruelty. So every week on this Mission Critical Briefing, we bring you news about what your donations are accomplishing, because this work does not happen without your support. So please continue that support. Make a donation before December 31st and have it doubled to go twice as far for PCRM. So an easy way to donate is to go online at pcrm.org. But if you'd rather connect with a person, and we'd love to do that, just let us know in the chat and we'll connect with you through the email that you registered with. So thank you so much, and let me turn it back over to Dr. Barnard for some closing comments.
Well, thank you so much, Megan. Thank you so much, Anne. Thank you so much, Betsy, for these tremendously important updates. And let me second what you just said, Betsy, about the importance of the support for our work. And I'm delighted that every donation is matched, because every dollar goes so far in meeting the goals that we share. Now, many of you on this call have a real heart for animals. And you might be thinking, gee, well, how does our clinical research on the gut or on blood types, how do these things affect animals? Well, as you can see, there's a thread that runs through everything, which is that we are showing that, first of all, plant-based diets, vegan diets are safe and good for you, but also we're showing that they have tremendous benefits that other diets don't have. Now, if you think back a generation ago, 14-year-old kid said, Mom and Dad, I think I want to go vegan. And pediatricians and everybody were aghast at this, because you're not going to get protein and you're going to waste away and so forth. But research then ended up showing quite the reverse, that not only is it completely safe, it's actually better than the diets people were on before. And so that's what our clinical research studies are showing. For people who want to lose weight, a healthy plant-based diet is the way to do it. If you've got diabetes, if you've got high cholesterol, all of these things get better and better and better when people get the animals off their plate. And of course, the animals are glad to be off the plate, and the environment breathes easier too. But as Dr. Lamb was describing, that when we're kind to animals in another way, leaving them out of the research cages, that at that point we are focusing on better research methods. And I have to say, I've been so impressed. Every year we do a huge medical conference, and researchers talking about the role of nutrition in the brain and the role of huge human cohort studies that have shown us, not in rats and not in mice and not in monkeys, but in human beings, how lifestyle changes can protect our cognitive health. It's really inspiring, both from the standpoint of health, but also from the standpoint of the kinds of research that need to be done. Of course, we're doing lots more here at the Physicians Committee. We're busily getting animals out of laboratory research overall. Many of you saw the wonderful successes that we had recently getting animals out of surgical training at so many sites, and we've got a lot more victories scheduled for 2021 in exactly the same direction. So all of that work requires a lot of resources, and if you are able to give $1, that dollar becomes $2 with this match. If you're able to give $10, it becomes $20. If somebody is in such a wonderful position that they're able to give $1,000 or $10,000 or $50,000, whether it's a small amount or a huge amount, in every single case, it's shifted into high gear and every dollar is doubled. So I want to say a special thank you. I've been looking in the chat, and I see lots of people whose names I recognize from prior calls and from some of the visits we've had here at the Physicians Committee. So let me just say 2 quick things. If this goofy pandemic ever ends and everybody starts traveling again, come visit us here. I'd like you to meet the whole team. I'd like you to see our digs and see the kind of work that we do. But in the meanwhile, our work doesn't stop, and I know your commitment doesn't stop. So thank you for being part of the team. Those of you who have donated, thank you so much for doing that. And if you're new to it, it's going to give you such a warm feeling to be able to power this work forward. So thanks to the whole team. Thanks to all of you. And next week, we've got a special program. We're going to be talking some more about what is ahead. So thanks to everybody, and back to you, Betsy.
Well, thank you, Dr. Barnard and Dr. Lamb and Megan, and for all of you for joining us today. And Dr. Barnard's right, we've got something special planned for you. Our very last Mission Critical of the year is next Friday, so please join us and have a wonderful weekend. We'll see you back here next Friday.